Hi guys, welcome back to the channel. I hope you all are doing good. So in this video we will be discussing a problem that appeared in the Leetcode July challenge. So if you're doing the July challenge, you would have come across this problem today. So this problem was on 23rd of July. Okay, so what is this problem? It is count of small numbers after self. So this is hard category problem. To approach this problem, you can't directly solve it. Like honestly, I was not able to directly solve. So to approach this problem, I mean first let us read the problem statement, then I'll tell you the approach. So you're given an integer array nums and you have to return count array. So count array has property where counts of I is the number of smaller elements to the right of nums of I. So let us take an example. So this is the array 5261. Okay, so how many elements are smaller than this number which are present at the right side? So 2 and 1. So there are two numbers. Okay, now next element, how many are smaller than this to the right side of 2? So starting from this index, starting from the next index, you have to take you have to consider all the elements that are present to the right side. So how many are smaller than 2? There is only one element, 1. Similarly for 6 also 1, and for this 1 there is nothing to the right side, so it will be 0. So basically this is what we are supposed to return. Now actually everybody would think of brute force only, brute force approach, wherein we can keep a pointer over here. So let us say, so what the brute force approach will be? Brute force approach will be very simple. It will be like this. We'll have a pointer I and then we'll say j equal to I plus 1, and j will traverse, and we'll compare nums of I with every nums of j, and we'll see which one is less than nums of I. So this is brute force, and obviously time complexity is O of n square, which is not advisable. So to optimize it, we have to look at some other approach. So if you try O of n approach, I'm not sure what it is. If anybody knows, you can. We can try next best is n log n. So whenever we have a mindset of getting n log n approach, usually some binary search. Okay, binary search, because binary search works in log n, and maybe there'll be n iteration, something like that, at least in our head it will be. Or we can use merge sort, because merge sort or quicksort runs in n log n time. So actually to approach this problem directly, it will be very hard. Okay, that is why it is under hard category only. So you should have, so what are the prerequisites of the problem? Prerequisites are, you should first of all know what is merge sort. Like proper understanding of merge sort you need to know. And if you have solved the problem count inversion, it is very famous problem. Okay, count inversion. So then this problem can be approached. So count inversion, I think, is opposite of this only, or maybe it's the same. I think it's the same of this only. So I think it's the same problem as count inversion, maybe some slight modification. So how do we actually use merge sort technique over here? So let us understand what exactly happens in merge sort to convince ourselves that we can use merge sort. So in merge sort, if we are given this array, what we do, we'll split this into two arrays, 5, 2 and 6, 1, correct? So merge sort is divide and conquer. We'll keep dividing the arrays until only one element remains, because when only one element is in an array, that is sorted already. So now this also will divide further. We'll have this as one array and this as another array. Similarly, this as one array and this as another array, correct? So now when we are merging, let us consider the merging process of these two arrays. So this array has element 5 and this array has element 2. So typically in merge sort, what we do, we keep extra space while we are merging. We keep extra space and we'll have a pointer I, which will be which will help us traverse the first so we'll call this array as left, and we'll have a pointer j for the right side array, correct? Now let me remind you, both these left and right arrays are sorted. We are going to be merged now. So in merging, what happens? So we'll check now. See, left of I, it is less than or equal to right of j. Is this condition true? No, it is not. So this condition is false. That means left of I is greater than right of j. Notice one thing, that I is less than j. See, I is less than j over here, because in the actual array, what are we comparing? What is I and j in the actual array? It is nothing but 0 and 1. So in the actual array, I and j is 0 and 1. So I is less than j. And when we say left of I is greater than right of j, so indirectly what that means? We have found an element at index I, and also we have found smaller element at index j, which is to the right side of it. I'll repeat that. We know that I is less than j, and if this condition is true, that left of I is greater than a right of j, that means we have found an element right of j which is to the right side of left of I, and in the actual array also it will be in the right side only. You can see that 2 is in the right side of 5. So we have found a smaller element. So what we'll do is, so now in this case, what happens when we are doing the merging process? What happens? So this condition, left of I less than or equal to right of j, is false. It is false. So we have to put right of j in our, if we call this as a temporary array. So we create a temporary array and then we copy all the elements to the original array, right? So in the temporary array, first we'll put right of j, then we'll put left of I. So what is this actually meaning? So now you can see, when left of I, that is 5, was placed, all the elements that were before 5 are less than 5, correct? So we need that count. So in merge sort, when we are doing the merging process, actually we are getting the elements that are smaller than ith element, but they are to the, maybe they are toward right side of the ith element. It is maybe, it is not always true, because if already the array is sorted, then nothing can be done, right? So let me repeat that. In merge sort, while we are doing merging, there are cases when we have an element, when placed in the temporary array while merging, that is placed such that all elements before it are less than that element, and they appear in the right side in the original array. So let us do one more iteration and check. So now what will happen? So this array is merged, but there are two more arrays, 6 and 1. So we have already found that, okay, for the element 5 we have one smaller element which is 2, but how do we keep track of the index value, the index values? How do we keep a track? So to keep a track of index values, we need to make pair of what? First of all, the element nums of I and the index. So this is going to be a pair, and we are going to do merge sort on this pair. So initially, like the original merge sort is only on an array which has one element. Here it will be merge sort on pairs. And why do we need pair? Because the second element in the pair is the index, and for every index I need to know how many elements are smaller than the element at that index which are present to the right side. So I need index value also. So this is important. So in this problem, that is why it is a hard problem to understand, that we can use pair STL, or you can make another custom data structure of your own. Okay, so we need to take pairs, and let us see one more iteration over here. See, consider 6 and 1. Okay, now we know that whatever index of 6 is, it is less than the index of 1. In the original array also we can see that only. So when we are merging 6 and 1, 1 will be placed first and then 6. So how many elements are there before 6? That is 1. Right, so that is one element. So that is why we can say that, okay, for 6 there is one element to the right side of 6 which is less than it. So now these two arrays also will be merged. So now what will be the final merging of the arrays? So you can see this is one array which was merged, and now this is another array which is merged. And what about our count array? So count array also will be size n only, and the current status of count array will be like this, because this is the original array and this is the indices. So for 5, how many elements are less than it? 2. But till now we have found only one element. We are yet to find this element for 5. So that is still to be done. But when the state of merging is like this is the count array. We know that 6 has one element less than it, 5 also has one. And now let us see the final merging process. Now when we finally merge this, again, this is left array, this is right side array, and we'll have a pointer I equal to 0 here, j equal to 0 here, whatever. You need not make left and right array, we can keep temporary array only. Like there are different ways of doing merge sort. I am not going into detail of how to do merge sort, so I expect that you should already know. So now 2 is there, 1 is there. See, now left of I is greater than right of j. So when left of I is greater than right of j, what we'll do? We'll keep a variable called right side smaller, which will tell us how many elements are smaller than the current element which are to the right side. So we can see when left of I is greater than right of j, we'll increase this pointer. So this will become 1. And now what we do? In our temporary array, we'll put 1 and we'll shift the j pointer here, and now we'll compare. Now what is left of I? 2, right of j is 6. So now this condition is true, left of I less than or equal to right of j is true. So when this condition is true, what we should do? In our count array, this is most important step, in our count array, we need to increase the index of this by how much? By whatever this value is. By whatever this value is, we need to increase that index. So this will now be increased by 1. And that is how even this became 1 and this became 1. So now this has become 1. And what will happen? I will go here. I will go over here. Then what happens? Now see, left of I is less than or equal to right of j. So what was our temporary array? Temporary array was 1 and 2. So 1 we processed, then went to 6. Between 2 and 6, 2 was smaller, so we put 2 here because we are doing the merging, right? And now we are comparing 5 and 6. 5 is less than or equal to 6. So what we should do? We should put 5. And we should also increase this index in the count array. We should increase this index by how much? Whatever the value of this is. And now this is also 1. So this will become 1 plus 1, which is 2. And what is this 1 plus 1 telling? See, when we put 5, how many elements are less than 5? 2 elements. So that is what this is telling us. So here the count array will be changed like this. So this will become count array, which means there are 2 elements to the right side of this index which is having a less value than the element 5 which is at that index. So basically this is how you solve. So while doing merge sort, so you need to know the merge sort code, and in the merge sort code, whenever we are doing the merging process, so when we do that, like I less than or equal to mid and j less than or equal to h. So when you're doing this merging process, right, here only some code you should write. Only this change is needed. Only this change is needed to solve this problem. So I hope you understood how the merge sort can be applied over here. So in general, merge sort can be applied to problems which are asking you to do something like this. Merge sort can be applied to the problems where there is an element at index I and there is also element at index j such that I is less than j, and you have to find some relation between nums of I and nums of j. You need to count how many elements are less than or equal to some equation. Okay, some equation you'll have to do, and while doing merge sort only you have to identify this. So merge sort can be applied in these kind of problems to reduce the time complexity to n log n. So where index I less than or equal to j is there and nums of I greater than nums of j, something like that. So this is where merge sort can be applied. So this part of the code, this part I'll show now so that you will have a better understanding, but I hope you have got an idea. So the merging process, when we are doing, always there will be an instance where while merging, element from the left index or the left array while merging will be greater than few elements in the right side array. So that count we can get. That is where we can get the count. And the whole idea behind this is the indexes are anyway going to be fixed. The relative positioning. So what do I mean by relative positioning? So if this is the original array 5261, the index of 5 is always going to be less than index of 6 or index of 1. So that is the major advantage of this technique. That is what is helping us solve the problem actually. So I'll show the code and you will be able to understand, because you will know merge sort. So first of all, merge sort. Before that I told we have to take a vector of pairs. So take vector of pairs. Okay, and pair is nothing but nums of I with I only. And also take count array. So basically count array, initially it has size of n and all values are 0. It represents what? How many elements are smaller than the ith element which are in the right side. So okay, that is done, and we pass it to merge sort. So merge sort, this is standard code. Merge sort, this is the standard code, and we are passing all these elements. These are the parameters we are going to pass over here, and this is the merging. So merging only the whole point is. So while merging, right, here we are saying if array of I dot first. So what is first? Basically first is nothing but the value. In the pair, first part is value, second part is index. So if array of I dot first is less than array of j dot first, less than or equal to. So in that case, what we said, we have to add at the index of the ith element, the index of the ith element, we have to add we have to add count of how many right side smaller elements are there. We have to update that value. Otherwise, if this condition is false, that means we have found a smaller element to the right side. So we increase that count. And also don't forget, when you are doing the merging process, there may be a case when the arrays are of unequal length. So there may be a situation when you are putting elements from the left side of the array and you are filling it, and you are not increasing the count of how many are smaller than that number. So this step is also very important. So don't forget this step. So whatever we are doing here also, right, we have to do here also. Why is that? Let me explain to you. See, consider a hypothetical situation. Okay, consider a hypothetical situation that the elements 1, 2, 3 are placed, and in the left array 4 is left, and in the right side array nothing is there. So in the left side array and the right side array, this is the situation. No element is there, left is there. Now when we are putting this 4 here, we observe that there are 3 elements which are less than it. there are 3 elements, so there may be an element coming from this right array also. So for this element 4, at whichever index that element 4 is present, we need to increase the count, right? We need to increase the count of how many were smaller than it, which are in the right side. So that is what is basically happening over here. And this is very important step. If you go wrong, you will get wrong answer. If you miss this, you will get wrong answer. So basically this is all entire merge sort code only changes are over here. And in this problem we need index also, so we need to make pair we need to make over here. That's all for this video. I hope you understood merge sort and how to solve this problem. So I'll see you in the later videos. Until then, take care, stay safe, keep learning, keep growing, stay tuned, subscribe and share the video so that it reaches more people. Bye.